Hi, good morning, everyone. Thank you for joining us today. My name is Isa, and I'm with SHIDC, and I will be your moderator for today. Before we begin, we're just going to go through a quick housekeeping check. The microphone for all the participants in this session are muted, but just to be sure, can you please check that it is muted on your respective devices? Unfortunately, due to our constraint on time, the raise hand reaction during the webinar will not be attended. But if you do have any general questions regarding today's session, please type them in the chat box. For optimal viewing, we recommend selecting the speaker's view. If you have any questions regarding the topic of today's session, you can type your questions in the Q&A box located at the bottom of your screen. We will address these questions at the end of the session. Thank you. The Malaysian Smart Factory 4.0, in part with Selangor Human Resource Development Centre, aims to deliver hands-on and competency-based training programs to support workforce and talent development in the fields of IoT and smart factory, led by Dr. Chua Wen-Shyan. Dr. Chua obtained his PhD in Control Systems Engineering and Bachelor of Engineering in Mechatronics Engineering from Monash University, Malaysia. His key area of expertise lies mainly in the area of control and automation systems, fault detection and identification, and predictive maintenance strategies, which are widely used in Industry 4.0 applications. This session will take about 45 minutes to an hour. Without further delay, I will now hand over to Dr. Chua to begin.
So very good morning, everybody. Thank you very much, Eza, for the introduction, and welcome to the Malaysian Smart Factories webinar series today. So this morning, I will share with you a topic on basically what we're going to discuss this morning is about a cost-effective approach towards digital transformation for a smart factory. My name is Dr. Chua, and I currently manage the Malaysian Smart Factory under the Selangor Human Resource Development Centre. So this morning, we'll be talking more about a different approach or a different perspective towards digital transformation. Basically, you probably have heard about Industry 4.0 and some of the key pillars of it. But what we will share with you this morning is how can you achieve a very cost-effective way of digital transformation and will be able to scale up more flexibly and attain sustainability through your business organization. So this morning, we will share on an overview on Industry 4.0. Just to catch up and recap on that overview. The integration of technologies for a smart factory, that's what we will discuss more. Basically focusing more on what data can do for you. That's the key takeaway point number 2. And of course, how training and a proof of concept that towards digital transformation can really help you and your businesses through this journey of Industry 4.0. So let's start off with the overview of Industry 4.0. So Industry 4, as we all know, it's basically a journey towards digital transformation and productivity. So if you look back at the past, where we started off at Industry 1, that sort of started off with the mechanization, steam power, and when we moved to Industry 2.0, it talks more about mass production and assembly line. That's where electrical energy came in. And of course, when we move forward into Industry 3.0, that's where automation, computers and electronics come in. So automation, if you think about it, is really more on the Industry 3.0 perspective. And then when it comes to Industry 4, it really talks about the Internet of Things, the connectivity of hardware and software, and basically networks of machines and devices connecting to each other, forming what we call as a cyber-physical system. And of course, basically is an integration of technologies altogether. Now, when we talk about smart factory, right, we really see it as an integration of technologies for digital transformation. So we usually hear about the pillar concept of Industry 4.0, where you have many, many pillars. But here we talk about the integration of those pillars in terms of technologies, right? So you have the horizontal integration, where all the technologies will be hardware software integration will be formed at the shop floor. And once you collect enough data, that's where you go up to the vertical integration, where your AI and analytics comes in. That's where your cloud or edge computing, if you're planning to go cloud, will really be there. That's where the cyber physical systems basically will be formed. And when you look at the overall data collection analytics, that's where you form what we call as a digital continuity. And that's basically where your digital twin comes in, right? And when you put this all together, right, you actually break down even further to only 3 components of an integration of technology for smart factory, where you talk about operational technologies, information system technology, and of course, eventually the digital factory. Now, Industry 4.0 is not so much about automation anymore, right? And when we talk about connectivity of machines and devices, what we really intend to achieve out of Industry 4.0 is really about digital transformation to achieve good productivity and optimization, right? So if you look at this chart over here, basically what it explains here is that you have a chart where time is the X direction and Y is basically your value of adaptation, right? So when there's an event happening on the left, right? When there's an event, basically if your machine breaks down, right? How fast do you know when your machine breaks down? That's your insight of the event, right? And when your machine breaks down, you need time to look into why it breaks down. And that's where your analysis completion comes in over here. And when you know why your machine breaks down, that's when you start to come up with your root cause analysis and you know what is the countermeasure that needs to be done. So you discuss with your management team and then countermeasure takes effect. So all these steps or process of identifying an issue to resolution, right? We call it an event to resolution. Basically, it's all time that is taken. It is time delay. It's considered as time delay. So you have insight, which takes time. You have analysis, which takes time. Decision making, which also takes time. And making an action, which also contributes to time. So the total time that you take from the time machine breaks down all the way to your resolution, that is a combination of all the time delays in this particular concept. Now, the main point of Industry 4.0 is really about minimizing this kind of time delays to ensure quick resolution, right? Because time is equal to cost, it's money, right? So you want to minimize all this time, right? And how do you achieve that is basically through collection of data, through knowing what's going on, having a good control over your data, and basically you have a lot of information and you can make the right decisions without very much delay. So which brings me to the next part, which is what data can do for you, right? In terms of Industry 4.0, we really want to focus on what data can do for us, what kind of information it provides, and how can we achieve optimization and productivity using the data that we collect through the integration of technologies. Now, the first thing data can do for you is basically once you collect them all together, you can form basically equations of effectiveness. For example, OEE, right? OEE stands for overall equipment effectiveness. And it's basically represented by a very simple equation, right? So you have availability, which is A. That actually tells you whether your machine is up or down and how frequent your machine is up and down, how long it takes for a machine to be down and how long your machine is idle, right? Then you talk about performance. Performance is basically your cycle time, your performance of your machine, right? How fast does it take to produce one cycle of products, right? We look at machine time, idle time. If there are slow stops in a machine, that affects your performance. You look at your elemental cycle time, and basically that gives you the overall performance of your machine. Now, your machine can run very, very quickly, right? It can move products very quickly. But the next question is your product produced up to your spec or standard? So that comes in as a quantity of quality, right? So you look at quality where you have key parameters such as, your pass fail, or you have products that are incomplete, which requires rework. It doesn't meet criteria or spec. So that comes in as part of quality. So if you put this all together, it actually gives you a percentage of efficiency, right? So basically your operation is not efficient if your availability is not up to a certain spec, your performance is actually very, very low, and your quality or wastage is actually very, very high. So that actually gives you an equation of effectiveness, and that's what data can do for you at a very preliminary step. So what else data can do for you, right? Basically, if we look at the evolution of maintenance strategies, right? Whenever we do maintenance, whenever we do fixes on machine, it takes up cost, right? So when you move from reactive to preventive to predictive, right? So reactive is a point where you fix your machine when it breaks down completely. That actually requires a lot of cost involved, right? And if you have no insight towards your sudden breakdowns, that will actually cause a whole machine downtime and it will delay a lot of processes in the line, right? So then people move to preventive maintenance, where they have scheduled maintenance to prevent breakdowns, where every month, for example, they actually change a spare part, or they actually do preventive maintenance strategies. However, although this can be effective, it can also bring in a lot of cost involved, because you have to put in spare parts, you have to change parts, which will actually not be, which is actually not spoiled. So therefore it incurs a lot of cost. Now, what if you can use data to predict when your machine will break down next, right? Or predict when your maintenance needs to be done. So basically that comes in as a machine health diagnostic. And that's where data can actually help you predict when is the next maintenance time that you need to look into. So the journey towards predictive maintenance, or basically when you use data, right? It's all about thinking, is my machine working or operating normally? That's where data can actually tell you when there's a problem with your machine, right? So you look at anomaly detection. So you have different techniques such as SPC, statistical process control, which actually helps to detect anomalies. Then you think about why your machine is not behaving properly, right? That's where predictive maintenance comes in. It will actually tell you which part of the machine actually is breaking down, and you can drill down further to where the fault actually is. So that's where in the curve just now, you take time from insight to analysis, and that's where the analysis time actually shortens. How long do I have before my machine stops running? That's a very good question that people usually ask. So with data and with trends that you collect over time, what you can achieve is basically better machine diagnosis, and you can actually look at remaining useful life, which will actually tell you when the machine is going to break down next. So in a very simple example of how predictive maintenance actually works is you think about it like a Google Translate, right? So if you want to translate from English to Chinese to Spanish, basically you have a language put in and it will translate it for you. It will detect and translate it for you. Now, when you look at machines, they do the same thing, right? But instead of having A, B, C, D, E, or different alphabets or characters, basically it gives you signatures in terms of signals, right? The signals are basically machine data signatures. So when you translate it, basically the machine can tell you using predictive maintenance strategies that it is not well. Basically, it is not well based on anomaly detection. One of the parts are loose. That's where your predictive maintenance comes in. And I will shut down in 15 minutes. That's where your remaining useful life methodologies come in. And all this basically is achievable through basic data collection. And that's what data can really do for you. So if you look at this curve over here, this actually provides a very good example of how predictive maintenance can really support your operations, right? This is actually a PF curve of a health of equipment over time. So if you look at this graph, right, there are 2 points that are very, very important. One is functional failure. That's when your machine totally breaks down, right? And you have potential failure where your machine is starting to fail. That's where you hear noises, for example, like if your motor is running, you hear probably like noises or vibration like, so that's when it tells you that, okay, my motor is going to fail anytime soon. I need to do something. So, but that's based on human experience, right? It's not based on data-driven techniques. So the point of predictive maintenance is really to look at the point where it actually starts to fail, right? So the point of actual start to the point of potential failure, that's where your predictive maintenance needs to come in. And all these strategies need to be done basically using data. And when you have data collected over time, right, when you look at the whole condition monitoring, you're actually able to determine the rate of degradation of the machine over time. And that's where predictive maintenance actually will be there to support you in detection of faults or anomalies early in the line, and will be able to identify these issues before it reached the point of functional failure. And that's when you really have a machine breakdown over time. So the idea is really to increase this PF curve interval and to maximize the performance of the machine over time. So now, if you look at this graph, basically it's how data is collected over time. and how you can actually see how predictive maintenance actually helps you to see that there is a problem in the machine. So if I collect my motor position over time, and this is actually the interval from the point of actual start of failure to the point of functional failure, right? Where you can see a peak over here. Now, functional failure is caused probably in this case by sensor malfunction, right? So if I'm able to predict, if you can see the bottom graph, that's the anomaly estimation, right? If I'm able to predict at this stage, right, at the early start, that my machine is going to fail, right? Then I'm able to actually identify it early and I can stop this peak over here from happening, right? And therefore, I actually bring forward, all the strategies of preventing this catastrophic issue where there's a sensor malfunction over here, and therefore reduce the cost of unexpected failures. So this is basically how data can really help you to provide insight over your operations. It gives you a lot of information about your system operations, your behavior, and therefore you are able to reduce the impact of failures onto your machine over time. And this is basically what data can really, really do for you. Now, of course, when you look at all the strategies that I've shared, right, what data can do for you, how it actually helps you, and basically provide you with a lot of insights, to your manufacturing operations, to your daily system operation. Now, the next question would be that I think a lot of people will ask is, all these things put together, how can I achieve it at a very quick rate? And of course, the next question would be, what are really the costs involved and how can I sustain this kind of operations for the future, right? So basically what we do at the Malaysian Smart Factory is basically to put everything together into one space. We are a technology training and development center. We do lighthouse projects. Our center has a live demonstration of technology, which I would love to show you, but unfortunately we are in the MCO period now, but you're always welcome to come and join. And of course, the digital training platform is an area where we will support the industries later on in terms of training and development online. Now, we actually broke down the steps to achieve good digital transformation at a very cost-effective rate through basically looking at Industry 4.0 maturity levels, right? So if you look at this diagram over here, we broke it down into 5 levels of stages. Where do you actually fit in this stage, right? Because a lot of companies actually talk about, all right, I want to have AI to do my analytics. I want to have predictive maintenance, right? And I want to do predictive analytics. So the first question I'll ask is, whether do you have data, right? And a lot of them say that, okay, I have data, but occasionally it's stored, occasionally it breaks down, occasionally it doesn't store well. I have bits and pieces of gaps in data. That cannot work, right? Basically, you need a trend analysis over time. You need to have consistent data collection over time. It should not be inconsistent, and it should not be, I have for this month, I don't have for the other month, right? So we broke it down into 5 levels, right? So level 1 to level 5. Level 1 talks about data generation, right? The first step is always to generate data. Next step is basically data visualization. So you need to be able to visualize your data and identify what are the features or trends in this system that you need to look at. Now, once you look at data visualization, you need to store, right? You need to make sure that all data is stored in a database where you can keep it for a long period of time. Your retention period is long so that you can really analyze those data later on through your analytics algorithms. So the first step after data storage is looking at data formulation. Quick wins, right? You want to identify whether your system has an issue or not over time, right? So that's where data formulation comes in. And once you have a lot of data, that's where you can form analytics models. And that's where the predictive maintenance will start to drop in over there. Now, when we look at data generation, right, is where we actually see how machine data is actually collected. And this is actually level 1. So this is actually an example of basically our system where we connect a gateway to a PLC-based lighthouse, and we collect data from the machine. And this is actually done through a non-PLC-based method where we can use signal tapping methodologies to collect data, and you can monitor your machine status, basically a tower light. You can also look at power consumption monitoring through smart devices. And all these can provide you with alert triggers, notifications, and of course, mobile applications, alert notifications as well. So this is basically level 1. You want to collect data. You want information. That's where you need to start off with. And once you have information, that's where visualization comes in, right? You want to be able to look at your operations. You want to see it over a time series, right? You want to see this particular visualization of data over a time series. So that's where data storage comes in. You look at storing all this data and you pull out this data to visualize them, right? So you store and visualize, and this is actually done basically through the platform that we have. We store the data on premise. We look at the machine status. We actually pull out this data from a database, and we are able to look at power consumption monitoring and a lot of other visualization parts of the information that we want to get from the machine. And therefore, we are able to dive deep down into what is actually happening to the machine over here, where you can see that there's a peak of power when there's a temperature increase. That's when we have a heater. So when you have a heating element, that's where your power goes up and your temperature will go up as well. So now, once you have all this data, right? You have all this data stored, you have all this data visualized in a platform like this. Next thing you need to look at is data formulation, right? You need to put the data together to give you good information about what is actually happening to your machine or what is actually happening to your production line. So that's when we put all the data stored in the database. We look at real-time overall equipment effectiveness. We really look at the total power consumption per day. That's where you see this graph over here. We really look at real-time environment temperature control monitoring systems over a time lapse. And all these platforms that you see are very flexible and scalable dashboarding platforms, right? And of course, data analytics is something we are working on. We have stream analytics probably coming soon. And that's where we will integrate all in our current smart factory environment that we have at the moment. Now, the idea is really to achieve what we call as custom-built applications, which are affordable transformation, right? So dashboards that you see like this over here and the previous ones that I showed, right? It can give you a lot of features already, like machine status, process time, control, product customization, real-time overall equipment effectiveness, email alerts, modular production control, and a lot more other features, right? In this kind of environment. Now, the big question mark is, now, how can I achieve this in a very cost-effective manner? And where do I actually start to actually develop these kind of platforms? Can I start tomorrow, right? And the answer is yes, you can. Basically, all the platforms that we use, right, from level 1 to level 5, what we are introducing here are basically openly available platforms that are powered by the community. And how these platforms actually help you to scale up further is basically because of its capability of being powered by the community, they have been rigorously supported. And therefore, these platforms are readily available for you to explore. And you can actually use these platforms to do your daily operations because these are already there for you. But what we do at the Smart Factory is we package all the developments of the hardware, software solutions. We package them into training programs like this, where we actually have from level 0.5, that's where our technology overview is. You reach the stage of 0.5 if you go there, right? So then we go into data generation, which is level 1, and we are able to teach you how to generate data very quickly. Machine data logging is also a program that we have, which helps you to get level 2 and level 3. Level 4 is where we talk about OEE, right? So we collect data and we formulate it. That's where OEE comes in. Level 5 is data analytics. That's where we will really look at all the data coming in and really help you to look into the data analytics portion. And one thing good about this strategy or our programs it is very modular, it is very flexible, and very scalable integration of technologies. Because in the smart factory approach, we always go with a multi-vendor approach, which is brand neutral. Basically, technologies that you implement should always have the capability to connect and scale up. That is a very important key criteria of a smart factory integration. It needs to be implemented, it needs to be flexible, it needs to be scalable. And how this is actually achieved is basically through open communication protocols. So machines or solutions need to be able to connect to each other. It needs to be able to talk to each other. And therefore, from there, this is actually achieved through open collaboration concepts. If you see a lot of the technologies out there, they have plugins. Those open concepts are usually plugins. They have a lot of connectors, and that's where you can put them all together. That's where the technology comes in. And a lot to do with Industry 4.0 is about rapid prototyping and development, right? You wouldn't want to take a long time to actually integrate all these technologies together, right? You don't want to take a long time to actually collect data from machines. Gone are the days where you need to use C programming, Python programming to really collect data. There are already tools out there which are drag and drop for you, which collect data directly. And all these are powered by the community. And basically how this actually supports is reducing the time to deploy for your manufacturing operations. So moving from data generation all the way to data management in a reduced time to deploy. That's something that you really need to think about when you put in technologies implemented in your smart factory. Now, when we talk about how this open collaboration and communication supports the power towards rapid scalability, right? You want to make sure that the technologies that you put in are able to be integrated easily. And that's where the integration and connectivity comes in. It has a feature where it's readiness to implement. The technologies that you put in are scalable, right? You need to think about scalability because today, technology A is very, very advanced. Tomorrow, technology A is not there anymore. And technology changes very, very quickly nowadays, right? It's as fast as how you change your handphones, right? Everybody is developing something new every day. So then you talk about technologies that are flexible and agile, right? It needs to give you an active environment for testing, right? You need to have ownership over your software. You need to have the environment for testing, validation to fit into your current process. And that actually allows you for lower upfront investments, right? Like the softwares that I showed you earlier, that gives you a very, very low upfront investment for you to test and develop and validate. And that's where you can actually think about where you want to start at a lower range, right? And platforms that you want to go with needs to be collaborative. It needs to have a sustainable platform eventually for innovation, right? Today, you may have technology A, but you want to have technology A version 2, which is able to integrate with other kinds of processes that you have in your factory. And that's where platforms need to be sustainable. And the very key important part is that it needs to be ready to replicate. Because in your manufacturing production system, you have one line, which probably you upgrade to the maximum, but then you can't neglect your other manufacturing lines as well, right? You need to be able to replicate all of that together. And therefore, this is how the concept of open collaboration comes in. So this is actually a success story, which is shared by one of our industries that we supported, from training to implementation. So what happened with this industry, basically, they did is this three-step approach, right? So first, they identified a team to adopt Industry 4.0, right? And then they joined our talent development program, which is basically the first step, level 1, they need to do is data generation, right? So then after the training, what they did was they identified a Kickstarter project. They want to do something easy for the management team to see that there is some value add towards the training and towards the implementation of Industry 4.0 technologies in their factory. So the very, very simple case of what they did was to look at machine downtime, machine process time, and machine quality. So that's where they collect data from a machine. And what they did was their machines are basically legacy. They have machines that are there for about 10 years, 15 years. But what they want to do is they want to collect data from those machines. And that's where data generation program helps you to collect data from legacy machines. So once they collect enough data, they are able to formulate the equation of effectiveness, OEE, that I showed you earlier, basically moving from manual calculation of OEE through writing on the whiteboard to actual automated data collection and formulation for them, right? And this project, actually, they completed it with a very, very minimal amount of time, right, of work days, right? They put it all together in a team. So, and now the software that they develop it in-house, basically is flexible enough, is scalable enough, and they can replicate it for other lines if they want to. So this is basically the concept of what I want to share with you, from training to implementation, and how it really helps you to build a very cost-effective way or approach towards digital transformation. So basically what this concept does is that it helps you to build a sustainable digital transformation, right? So where you are is basically you have talent development programs, you upskill your workforce, you integrate and implement technologies, you develop basically your own in-house experts, right? You skill up and scale up your workforce in your factory. They're able to adapt through changes in technology, changes in demand. You actually provide expert job level opportunities. application-based R&D. And when there's a technology change or economic changes in the current situation, like what we have now, there are changes in job skills required. And that's where you come in again for talent development. And that's where we will help you to skill up to scale up, right? So the idea of Industry 4.0 is more than just technologies and process, right? The three components. It's really about the people, right? And with the people that you have, you can actually empower them or motivate them towards achieving your company goal of Industry 4.0 to really help you to build up a sustainable digital transformation ecosystem. So that's where leadership commitment comes in. You need to have, you need to apply the concept of change leadership through a changing time. You need to define Industry 4.0 roadmaps. Then you identify change ambassadors in your factory environment. You set up innovation teams. So this is a very important part. You need to set up innovation teams to help you to build up this platform. And where you need to help them is through talent development programs, right? As what we offer from level 1 to level 5. And then from there, they can identify Kickstarter projects to help build the culture of change towards digitalization in your factory. So that's a very key important point. Work with easy, quick wins to actually showcase what digitalization can do for you. For example, if you have been taking temperature manually every hour, right? Which is very laborious task. It's a task of one person collecting the temperature and humidity every hour. What if you can automate it and you can release that staff to do something better, which is they can look at the trends of humidity or temperature, and it can actually do other tasks in the factory, which is the highest skilled task. You don't need to do laborious tasks anymore. So that is sort of a quick win project for you, which can actually start to create a culture of digitalization in your factory. So generally what I've shared with you is the concept of digital transformation, which you can look at affordable transformation methodologies and concept towards your smart factory journey. So during this MCO period, I think it's a good time for you to look at some of the strategies that or build a roadmap that you want to look into Industry 4.0, like what I shared with you earlier, with your people. We have a brochure which you can look at in terms of the programs that we offer from level 1 to level 5. If you have a lot of questions that you want to ask, which I think you do, please do get in touch with us. These are the platforms that we have, which you can check in with us at any time. We will be having more webinar series following up from this, and that's where we can showcase some of the other concepts or give you insight towards innovation of technologies towards your factory environment. And of course, during this time, we actually want to hear from you. What is your training needs or requirements, and how is the training delivery mode moving forward from here? That's where you can look at training and development workforce survey that we have. You can take a snapshot of the QR code. Please help us to fill in, give us some data and information that we know to support you in your process of digital transformation. And with that, that's all I have to share with you today. And I will open the floor to any questions available.
Thank you, Dr. Chua. I'll now pass it on to my colleague Eileen to facilitate the Q&A session.
Thank you, Isa. Good morning, everyone. Welcome to the webinar. My name is Eileen. I will coordinate the Q&A session. We'll start with two questions posed in the Q&A box from Mr. Chong Sin Hao. First question is, how if our factory needs to do data generation? Dr. Chua, would you be able to support that, answer that question, please?
Yeah, sure. So basically, to do data generation, it all starts with basically the method of how you want to collect the data, what equipments you want to collect the data from, right? Because if you look at collecting data from machines, you need to know where the sensors are located. You need to know what signals to actually tap, right? So once you understand what are the information that you really need, right? Are you taking it as an on-off signal, digital inputs, or are you taking it as analog input, which gives you a increasing trend like temperature, right? So it really depends on what are the areas that you want to generate data. And that's where I think we can support you if we understand your requirements. And basically the way that we can generate data more quickly is basically from the chart that I showed you earlier. If you look at this particular chart, level 1 is where data generation comes in. All you need is the hardware involved. If it meets your spec towards your application, you can directly already implement it with the technology or software that you want to generate data from, which is over here, we have indicated a software that we work with. So this actually helps you to enable data generation at a faster rate. However, we need to understand your requirements. So if you can let us know further, that will be much appreciated.
All right, thank you for that, Dr. Chua. Next question also from Mr. Chong. How can this data collection help a mall?
Right, so I think data, we can really look at how in a shopping mall environment, right, it really looks at probably people flow, right? And I think some of the shopping malls have started the concept of, if you think about license plate recognition, right? So what actually it does, it actually provides information to the shopping mall operator of who is actually coming or frequently coming to the shopping mall, right? So let's say, for example, if my car number plate is ABC123, right? So today ABC123 came at 2 o'clock. Tomorrow ABC123 came at 5 o'clock. Wednesday, my ABC123 came at 8 o'clock. But then 1 month later, ABC123 did not come anymore. So that sort of gives you information of people coming in and out of the mall, right? And if you see that there's a frequent trend that they don't come anymore, that's when the mall operators can send reminders, promotions, you know, to their emails to actually encourage them to come back. So this is how data can actually sort of predict behavior, you know, over time. Once you collect enough information and you know enough information of your trend in a shopping mall, that actually gives you a lot of insight towards your operations, and then you can actually do more promotional or marketing capabilities from there.
All right, thank you for that. I'm going to move on to the chat box where there's some questions as well from MC Lim. Hi, for preventive data, just wondering if you're referring to external sensors or internal embedded in individual devices.
For preventive maintenance, when we talk about preventive maintenance, it really depends on what are basically the areas where you need to change, right? Or to basically during your preventive maintenance strategies, you need to have scheduled maintenance, right? So what do you intend to change, and what basically you want to replace the parts to ensure that your machine cycle continues to run. So if you look back at this curve, right? Let's look back at the PF curve, right? Now, preventive maintenance will help to probably increase your PF interval, because once you actually run preventive maintenance, you actually push back the start point of the potential failure back to a healthy condition. So what you're actually doing is you're increasing your PF interval, right? But essentially, does it really warrant a change of equipment, right? That's a big question mark to ask. So when we talk about predictive maintenance, right, you need to collect data from machines, and you need to identify first what are the parts or what are the key parameters of the machine that you want to actually check. So for a motor, for example, you may want to check into current, right? Your current input, and also maybe look at vibration. You may want to look at the performance in terms of reaching its actual speed or torque or position. So all these can give you information on when your machine is potentially going to fail, right? And from there, that's where you can do predictive maintenance, and that's where you can achieve your a good insight to move your potential failure point to an actual start to solve your problems.
All right, MC Lim also has another question. He says,
yeah.
When referring to database, may I know what is your opinion whether ERP, MES, or automation database can be standardized to one database platform? If that is possible, what is a good platform to use, which is reliable?
Okay, so ERP and MES, I think there are a lot of providers out there, which I think at the moment, they do support some integration. You will need to look at, in terms of database, you will need to look at platforms that are openly available, in which case those platforms are able to integrate with most ERP or MES systems. So for example, if you talk about database platform like MySQL, PostgreSQL, those are actually integratable to most of the ERP or MES systems that you probably want to use. So the first question that you probably need to ask the provider, right, the software provider of ERP and MES is, what are the plugins or what are the connectors available for you to push data to those systems and also to pull data out, right? I can't tell you which platform is the most reliable at the moment, but I would say that if you look at the platform, if you look at the open connectivity part that I shown over here, basically whatever platforms that you choose, it's really up to you. But you need to understand whether they are whether they can be easily integrated, they are flexible, and they are scalable, right? That's the most key important point, which I would like to highlight. Yeah.
Okay, we move back to the Q&A box. We've got a question from Ms. Marina Yao. Whom should be involved in level 1 to 5 training? Will they all be of the same group of people that has been selected to be upskilled?
Okay. So if you look back at this level 1 to level 5, right? Usually I would suggest for them to be the same team or part of the innovation team that you sort of will set up, right? So those members from the innovation team should be skilled up from level 1 to level 5, right? So they need to know how data is collected and how to analyze the data later on. Now, why I say this is because you can have one person working in a separate team to look at analytics, right? But if that person is not a domain expert to your production operation, that is going to delay a lot of time to actually get insight on the actual operation and what the signal actually is all about, right? You can show me a signal and I could probably look at it, but I will not be able to tell what is actually happening. So the engineer that is involved from level 1 to level 4 should also be involved in level 5 or at least be part of the team to actually work on this development so that they can actually scale up at a faster rate. Yeah.
Okay, thanks for that. Going back to the chat box again, we've got Muhammad Ilyas from Omra, Malaysia. He needs advice on cyber security information leakages, whether we go for IoT or cloud.
Okay. So basically, on the shop floor, when you have all these devices connected to each other, you basically need to have what we call as a DMZ zone for your operations, right? The more critical areas is always your manufacturing processes. You don't want to have penetration attacks going on onto your manufacturing operations, which could lead to catastrophic problems later on. So what you need to probably do in terms of cybersecurity or at least to secure your area is to make sure there's a DMZ zone, demilitarized zone, where all your data that you collect will be analyzed and controlled on the edge, which is the shop floor. Only information that you want to display or to visualize for management, operations, and so on should go to the cloud. It shouldn't be the concept where we keep on sending every data up to the cloud and then to analyze and then push back. Now, what happens with that is that you could risk latency problems, right, in terms of information coming back. And of course, when you have a lot of data being pushed up to the cloud, what happens later on is that your cost of storing those data is going to increase as well, right? Because all the data sets that you send up to the cloud may be charged per megabyte, right? So you may really want to think about that. And even though you may think that today I have maybe 1,000 data sets, it's not going to affect me in the long run. But the day when you move into predictive maintenance, that's where your sampling rate starts to reduce, right? Starts to be very, very fast, like every second or every millisecond. You can't be sending all your data every millisecond up to the cloud and come back. So you may want to think about edge kind of analytics. And our platform that we suggest over here are always looking at edge kind of solutions first before we go into the cloud. Yeah. Yiling, sorry, your microphone.
Sorry. Okay. We have a question from Mr. Ramendran. Where does reliability-centered maintenance fit in a smart factory?
Reliability-centered
maintenance. Where does it fit in a smart factory?
Okay. If I understand correctly on reliability, it really looks at the machine's health condition, right? So if you look at the machine health condition, that's when you look at condition monitoring methods. So in terms of this graph, what you want to see is condition monitoring. And when you collect enough data, that's when you can see what are the trends of your machine. And that's where you can really look at reliability of your machine as well. And reliability, I think, also looks at the remaining useful life of a machine. So you may want to look at how many cycles, for example, you collect enough information to understand the cycle trend over your equipment trend. And that's where you can see some form of data set that will give you some features. And that's where you can actually provide more information about reliability. However, if I didn't answer this question correctly, please let me know. Maybe you can provide a bit more elaboration and I'll try to advise further.
Okay, thanks for that. Moving on, we've got a question from Choi Wai-Sing, who is asking, can I know how much is needed for us to spend as a beginning stage of simple OEE implementation?
Okay, so this is a good question. It really depends on, let's say, your machine, what is your machine operating and what is your parameters that you want to monitor in terms of OEE. So, like, for example, what we share in terms of this particular project, right? So basically, what they wanted to do was to monitor the machine availability, right? So this actually can be given through tower light indications, right? Your red, yellow, green. So if you have tower light indication, it will tell you if the machine is down when it's red, machine operating when it's green, or machine under maintenance maybe when it's yellow, right? These are maybe the few common traits. So from there, you can actually get information on availability, right? So the next question about performance. Performance is all about how many cycles your machine run and how fast you complete one cycle, right? So how do you determine a cycle? Basically, is from your input to your output. So you need to probably have sensors indicated to have where's your input and where's your output. And from there, you can actually generate what we call as performance. So basically now you have maybe 6 key parameters to look at: red, yellow, green, which is tower light. And then you have input and output signals from your performance. And quality, basically, is all about rejection, right? Rejection or pass-fail criteria. So you can implement, if your machine gives you an indicator of rejection, then you can actually tap signals from there. And you can actually monitor those signals, which will give you a rejection criteria. So from there, you already have the key parameters to start for one machine for calculating A, P, and Q. So you need to look at a hardware that will give you enough input signals to determine what is A, P, and Q, right? So assuming that you have 10 inputs required, so a hardware, for example, the one that we use, which is a Siemens IoT gateway, can already take in 10 digital inputs, which you can actually collate them together to form, what is your OEE parameters. You can already generate that signals, and you can already do data formulation from there. And how much the equipment costs basically is, for example, for that kind of equipment, the hardware itself costs maybe less than 3,000, right, to put it all together. And what you need to do is to look at the software portion next. So the software that we use are openly available. You can use them. What we do is we teach you how to do it. And if you look at the talent development side, that's where you probably have a cost. But of course, we can look at programs that are HRDF claimable. Those are our programs. And that's where you can tap into your levy, utilize it maximum, right? And make use of whatever grants available from HRDF as well to really scale up your workforce to achieve OEE implementation. So you can sort of put together the overall cost now, and you can see that it's not very expensive to start one machine.
All right. Next question from Ken Chow. Level 5 data analytics stream and batch analytics, are they coming soon? Please elaborate on timeline. Is it too early to move on with technology which has yet to be ready?
Okay, data analytics is something that we already are teaching in the Smart Factory. What we do is we will teach you using softwares that are not the regular Python or R programming. Those software that we use are drag and drops, and those are basically softwares that you use previous data, historian data to actually build a model of your system, right? So when you talk about stream or batch analytics, it's already there. The technology is already there. We have identified a platform that we will work on. The timeline for this implementation of stream or batch will come in a bit later because we are working on it. However, in terms of the concept of data analytics is what we offer, right, at the moment. And you can actually join our program. You'll understand all the key concepts of machine learning, all the data analytics features, feature extraction, characterization. And that's where you can actually start to implement it very quickly. The reason why we use platforms that are as much as possible low-code frameworks is because we look at engineers or technicians that are not programming background centric. so they are able to actually hop onto these technologies very, very quickly.
Okay. Going back to another question on training, it's from Alvin Kang. For training from level 1 to 5, is there any prerequisite requirement? For example, must someone have a background in data science or IT? What about the project that was mentioned, the success story? How long did the company took to complete the project?
Okay.
Two questions.
Yeah, no problem. So for the training portion, in terms of prerequisite, usually we will recommend for people to have engineering background or computer science background to actually undertake our programs, because it's easier for them to pick up, or it's more relatable. That's what I would say. However, we do have participants coming from many ranges of background, right? We had some participants from a biotech background who joined our data generation program. So they also could pick up, because the platform that we use is very much drag and drop, right? So it's not very fixed to the field that you do. It's more about the interest and passion for you to work on it. So as long as you understand the fundamental competencies, or you can apply it, scaling it up should be no issue. But most importantly, they should have the passion to work on the equipment. They should be the domain experts to be actually coming for the training programs. In terms of the project that I mentioned, how long a company took to complete it? Well, we did allocate a number of work days to complete a certain project. However, to actually collect data from a machine, to actually start to populate it to a system, to a dashboard that you can see. So let's go back to here. Let me go back to this particular thing. So let's talk about level 1, where we collect data from a machine and then we straight away could put it to a dashboard. This can be, most of the time, once you allocate the right team to be involved, this particular portion of collecting data to visualization on a dashboard like this could be done within 10 working days, for example. So it really depends on how your team is formed. There's a task force involved, and we can be there to support them through that process of data generation part.
All right, I hope that answers your question, Alvin. Moving back, MC Lim would like us to re-explain or explain in more detail. Question on database platform. Is it possible to combine ERP, MES, and automation database in one platform?
Okay, all right, so that is actually a good question. And when I talk about smart factory and I talk about integration of technologies, it's all about putting everything together in one single platform. So I would say that ideally it should be possible, okay? But it really depends on what is the platform that you use in terms of ERP, MES, and automation, right? You need to make sure that they have plugins, they have connectors to be integratable, right? If the platform is not able to integrate it seamlessly, that will give you a potential problem. So I think the main part that you need to check when you look into buying those kind of software or technologies, really ask yourself this question. Is it able to integrate or connect overall? Is it flexible enough to be scalable? And is it collaborative? Because all the platforms that you have need to be able to talk to each other, right? So like, for example, the platform that we start with, like Node-RED, for example, it has connectors to database like MySQL, to InfluxDB, to PostgreSQL. So all these are connectors which we can then push out data towards these kind of platforms. So does your MES or ERP system have that kind of connection capability? So that is a good question to ask. And I believe that a single platform is possible, but it really depends on what you intend to achieve. Like, do you want to just visualize everything together in terms of data? If you want to do that, then yes, you can pull out data from your ERP, you can pull out data from your MES, and you can display on your visualization platform. That should be no issue. It's just basically pulling information out of a database, and that is more or less possible. So if you're really looking at just visualizing those information, that I can say should be possible and should be doable.
All right. Okay. I hope that answers your question, Mr. Lim. Please do check back with us either through this platform or via email directly with either myself or Dr. Chua if you have more detailed questions or inquiries. Okay, moving on, we have a question from Michael Chua. How do you protect the master controller or PLC from being hacked, as we cannot install antivirus?
Yep. So, well, most of the time when we talk about machine level shop floor connectivity, we need to make sure that your shop floor, all right, or your machine level controllers are not being exposed to the outside world, right? You need to make sure your ports are closed, right? It's the same as if you talk about your home security, you always make sure that you have a closed door, closed gate to actually protect what is inside, right? So similarly to your applications of a factory as well, you need to have ports that are closed so that you prevent people from hacking into your system, because the vulnerability comes from the ports that are open, right? So then in your particular factory, what you can actually do, or what we actually did, was to have a central PC. We should call it a module controller. And that's where we actually will do all the PLC upgrades, or information goes into that. And that module controller is where we will actually implement all the security measures, right? Because your module controller can be PC-based. So when you have a PC-based system, that's when you can have security measures put in. And that's where it will actually protect your overall line of controllers that you have. So the main point is not to expose your PLCs to the outside world. So you need to make sure that your ports are always closed, and to implement the right firewall strategies for your company.
All right, we have another question from Mr. Ang Chin Xiang. May I know, how do you normally convince top management or government sector on security? Most of us are very paranoid about having to get data access from outside.
Okay.
Question on cybersecurity.
Okay, so I think in terms of data access from outside, you really need to think about how you want to access it, right? And what are the kinds of data that you want to access. And this is actually the time, this MCO period is actually a time where we really think about how do you access database from your offices, right? And most of the offices actually implement VPN systems, virtual private networks. So from there, you can actually access a virtual private network to get whatever information that you want to get. So meaning to say that your data is not basically sent up to the cloud directly, right? You have a virtual private network which actually you can access to achieve that kind of data collection, or to monitor that kind of data collection. So that sort of solves one part of security, right? You have a virtual network to go in. So security measures can be there. Now, if you want to go onto cloud platforms, most importantly is you need to understand which platform you go with, right? A very good question would be, like for example, Azure, Microsoft Azure, or Google platform, or any other AWS platform. If you think that these platforms are easily hackable, then you may not want to go there, right? You need to understand what is the key security aspects of that, right? Because these kind of cloud platforms were designed to have the most sophisticated cybersecurity measure. That one I can say, right? So if you think a hacker can hack Google, then you may not want to go there. So you really need to think where you store your data. It's like where you store, basically it's like storing money in the bank, right? You put money in the bank, it's safer, or you put money in the house, it's safer. So you need to think about that portion, and what are the security measures in place. And of course, how you protect those data, which is basically like money involved, is something you need to think about where you want to store it. Yeah.
Okay, he has a follow-up question. He says, what is the recommendation whether to host the data in-house, on-premise, or in the cloud, and what would be the industry practice at this point in time?
So most of the data, we will always do it on the edge. Number one is because of we don't want to have a data latency when you only get information once it goes up to the cloud and come back down. We want everything to remain on the shop floor. That's your horizontal integration, right? You want everything, every data storage or every data connectivity to be done first on the edge, right? Then only some of the information that you require to be visualized offsite by maybe your management team or so on, then you can send it up to the cloud. Or if you want to do some big analytics that you don't want to invest in an on-prem platform, then you can push it up to the cloud. That is okay. But if you want to talk about machine control or you want to talk about machine decision making, it's always best to be done on the edge. And there are a lot of edge-based platforms available, which you can work with. So always think about keeping all the controls and monitoring on the edge first, and only push some information to the cloud, right? And that way you actually save a lot of cost, and that way you actually make decisions much faster. If you look at the graph initially, it's about having insight, the time for insight to analytics. If you go up to the cloud and come down, you may actually risk that time delay being bigger. So you want to keep everything short, and you want the alarms or alerts to come in very, very quickly.
All right, thank you for that. 2 more questions, 3 more in fact. We have one from James Chiang.
Yeah.
The data analytics mentioned in the slide just now, K9, data EQ, do they need human intervention or are fully automated?
Okay. So these platforms that we work with, so most of the platforms, they have, there are some features which are powered by the community, which is basically they are open source, so you can access them and do it manually. That means you have to, basically human intervention, you have to click and analyze. But they do have enterprise versions as well. So those enterprise versions are where you will fully automate your process on-prem or in the cloud. So the key part of this is basically like, if you want to learn how to use the tool at a very cost-effective rate, which means lower upfront investment, that's where platforms like this comes in very, very handy. So once you have a lot of data, right, a lot of data coming through every day, and you feel that, okay, it's time for me to invest in an automated platform, I have the guys to implement it, that's when you can put in your investment. But you see, what we are trying to encourage here is a lower upfront investment for you, so that it becomes more cost effective for you to start. And once you get used to it, then you can think about investing further.
Okay, thank you for that. Last 2 questions. Back Mr. Chong Sin Hao again. If we would like to collect data of energy consumption, is there any device that is compatible to collect energy data?
Okay, it really depends on basically I think it's more on the current rating and the power rating that you want to collect data from. If your machines compatibility are, you have a very high current rating, then of course you can use current clamps, current transformers, which will help you to collect current data. Or you can look at smart devices, right? For example, like our whole RFID line is actually monitored through smart plugs, right? So we have smart plugs all around the line, which are Wi-Fi enabled, and those smart plugs actually generate our power consumption on a daily basis, right? So it really depends on what is the level of your current that you want to collect data from, because some plugs or devices may not be able to support. So then we need to look at hardwares that are able to support your data collection of energy consumption. Yeah.
Okay, last question for this session from Choi Wai Sing. Inside a complicated production floor, there are many data that can be collected. Can we know how to define the most important data that we shall collect, to analyze and to utilize it?
Okay, so this is a very good question. Basically, the main point about collection of data is basically you need to collect data that provides you with insight of your operation. You don't want to collect data that doesn't give you any information. Then you are not able to actually characterize a feature, right? So let's say if you talk about motor, let's say you talk about predictive maintenance for a motor, right? Which part of the motor actually gives you the most information about a failure that's going to happen, right? Is it current? Is it voltage? Is it power? Or is it vibration? Or is it actually your rotation speed? So all this you can see which data will actually give you the most information, and that's where you need to collect the data from. Then, of course, when you look at the entire production floor, right, you need to look, let's say per machine, if you want to look at OEE per machine, you need to identify these few things. How do you identify availability of the machine, right? You need to know what actually are the key sensors that identify the availability of the machine. So for example, a tower light. Tower light is the most simple example, which will tell you machine down, ready to go, or under maintenance, the 3 signals that you have, right? So that will give you a lot of information already. Then the next part is, how do you identify performance of a machine? Is it input and output? Or do you identify it through a different process? Like for example, we had a customer or a factory where their performance is based on how fast you stamp or you press the button, right? So from the time you press the first button to the next button, that is a performance. That's your cycle time. It really depends on every operation that you can think of in a factory. That's your cycle, right? And then when you talk about quality, how do you identify quality? Is there a measure that you have? For example, is it based on weight, or is it based on vision, inspection, or is it based on operator dependence, where they will click, reject, or pass? So all this information is where you can collect data from those sensors, because sensors basically is only two types, right? You have digital inputs or outputs, or you have analog input or outputs. So digital means is yes or no, right? It's on or off. So once you have that information, that also works. Or if you want to look at analog signals, that will give you a more of a trend. For example, temperature gives you analog signal. You cannot be cold or not cold, right? So that actually gives you more information of your operations. So you need to know what kind of data is important for you to analyze on a daily basis, or what is your key parameter that you look at, what is your key characteristics, and that's where you need to identify or drill down, and you can collect and analyze those data.
All right. Thank you so much, participants, for your questions and comments. I will hand the floor back to Isa, our host.
All right, thank you, Yilin and Dr. Chua. Before we go, we would really appreciate if you could spend some time to provide us with some feedback by answering the poll that we just launched. So we just want to know if the webinar met your expectations, and did it improve your understanding of Industry 4.0 for the manufacturing sector? And will you continue to participate in future SHRDC webinars? The poll will close shortly, and we'll publish the results. In the meantime, if you look at your screen, we have some contact numbers if you need them. All right, thank you everyone for giving us feedback. And thank you for joining us in today's session. We really hope it's been beneficial to you and your company. If you have any other questions, please feel free to visit us at shdc.org.my or contact us at the numbers on the screen, and have a good rest of the day.